Hello everyone, this is Badrinath Malkapuram of Vellore Institute of Technology at Vellore campus. So, for us, we have been assigned a assignment for this subject called Computer Organization Architecture. In that assignment, we have to discuss about a microprocessor that of our choice. So, my name is Badrinath Malkapuram. I'm from 18BEC0394. My serial number is 31. So I have chosen the microprocessor Intel Pentium Gold D6600 for my assignment. So here the sir has the first question about the block diagram of the microprocessor that I have chosen. So I have chosen the Pentium processor G6600, the Pentium processor family. It belongs to the Pentium processor family. With providing the needed for the mainstream desktop applications as well as for the workstation and servers. The Pentium processor is compatible with the entire installed base of applications for DOS. The pipeline floating point and unit delivers workstation level performance, separate code and cakes, data cakes reduce egg conflicts with remaining software transparent. The Pentium processor million transistors and it is built on Intel's advanced 3.3V BIC MOS silicon technology. As one chip dual processing support a local multiprocessor interrupt controller, and the block diagram is as follows. So this is how a block diagram looks like, and I have already shared a separate file to this sir using a software where I have drawn it, and we can see the block diagram shows the two instructional pipelines. The block diagram shows the two instruction pipelines, the U pipe and the V pipe. V pipe and the U pipe. The U pipe can execute all integer and floating point instructions. The V pipe can execute simple integer instructions. In the FXCS floating point instructions, the separate code and data eggs are shown. The data egg has two ports, one for each and the two pipes. The data egg has a dedicated translation look aside buffer TLB called as TLB to translate linear addresses to the physical addresses used by the data egg. The code egg bands target buffer and prefetched buffers are responsible for getting raw instructions into the execution of the Pentium processor. Instructions are fetched from codec or from the external bus. Branch addresses are remembered by the branch target buffer. The codec as TLB translates linear addresses to physical address uses the code egg. Branch prediction is implemented in the Pentium processors. To support this, Pentium processor implement two prefetch buffers onto prefetch code in a linear fashion and on that prefetches code according to the BTB, so that needed code is almost always prefetched before it is needed for execution. System management mode. System management mode has been implemented along with some extensions to the SMM architecture. Enhancements to the virtual 8086 mode have been made to increase performance by reducing the number of times it is necessary to drive the virtual 8086. So this is about the block diagram. So for the second question, Sarah has asked the internal diagram of each and every block of the microprocessor. So this is how a top side view of the microprocessor look like. This is Pentium Gold G6600 processor called as an integrated circuit. This is the pin side view where we have to connect that. And this is the other type of a block diagram, the flow chart of a block diagram. So here the system bus has goes into the bus interface unit 64-bit plumpets 3.2 GBs and hardware data prefets and two ALUs, two AGUs, AGUs and a floating point register file all are in this Pentium processor. So discussing about the above flowchart, describe the name Pentium processor will be used to refer to these products. Pentium processor at 200 MHz Original Pentium processor, the name Pentium processor 60 will be used to register to original code original 60 and 66. The Pentium processor family architecture contains all of the features of the Intel 486 CPU family, same as the Intel 486 CPU family. Is same as the Pentium processor and provides a significant enhancement additions, including the following architectures: superscalar architecture, dynamic branch prediction, pipeline floating point unit, improved instruction execution time, separate 8K code and 8K data X write back, MESI control protocol in the data 8 64-bit data bus cycling pipelining, address parity, internal parity checking, functional redundancy checking, execution tracing, performance monitoring, IEEE 1149.1 boundary scan. These all are used. And the application instructional set of the Pentium processor family includes the complete Intel 486 CPU family instructional set with the extensions to accommodate some of the additional functionality of the Pentium processors. The floating point used unit has been completed redesigning of over the Intel 486 CPU. Faster algorithms provide up to 10 times the speed up for a common operation, including add, multiply, and load. Pentium processors include separate code and data eggs integrated on chip to meet performance goals. Each egg is 8 kilobytes in the dedicated translation look aside buffer. The Pentium processor have increased the data bus to 64-bit to improve the data transfer rate. Burst rate and burst write back cycles are supported by the Pentium processor. In addition, bus cycle pipelining has been added to allow two bus cycles to be in progress simultaneously. The Pentium processor memory management unit contains optional extensions to the architecture which allow 2 megabyte and 4 megabyte page sizes. So second question, this had asked about the provided instructional set of microprocessor element with clock cycle required, machine cycle required, memory required, all of the things required. So first of all, the Pentium processor supports clock control. When the clock to Pentium processor is stopped, power dissipation in virtually is getting virtually eliminated. The combination of this improvement makes the Pentium processor a good choice for energy efficient desktop designs. Support and upgrade socket. Thus, in this system, will provide end-use upgradability by the addition of a Pentium overdrive processor. Typically, applications will realize a 40% to 70% performance increase by addition of a Pentium processor. Socket 7 has been defined as the upgrade socket for the Pentium processor. We can see this in the block diagram. Socket 7. And next, coming to the Pentium processor supports fractional bus operation also. So Sarah asked about the bus operation in the question. This allows the internal processor core to operate at high frequencies while communicating with the external bus at lower frequencies. The Pentium processor contains an one-chip advanced programmable interrupt controller. This APIC called as APIC. This APIC implementation supports multiprocessor interrupt management uh, with symmetric interrupt distribution across all processors, multiple input-output subsystem support, 8259A compatibility, and interprocessor interrupt support. So this is all the pin cross reference by pin name data. This all has been said. Design notes for reliable operation: always connect unused inputs to an appropriate signal level. Unused active low inputs should be connected to VCC. Unused active high inputs should be connected to ground. No connect pins must remain unconnected. Connection of NC pins may result in component failure or incompatibility with processor steppings. So we'll quickly go into the pin reference. This section gives a brief function description of each of the pins. For a detailed description, see the hardware interface. The symbol at the end of signal as signal name indicates that the activate or asserted state occurs when the signal is at a low voltage. When a as symbol is not present after the signal name, the signal is active or asserted at the high voltage level. The following pin exists on the Pentium processor have been removed from the Pentium processor. 6066 have been removed from the Pentium processor. This is the new one. Microprocessing element in the third question. Uh, the Pentium processor have increased that the data bus to 64 bit to improve the data transfer rate. So that is, we can say that it